In this video, we're going to multiply radical expressions with the same index. In this example, we're asked to multiply the radical expression 3 times the cube root of 2 times 6 times the cube root of 3. Now, when we're multiplying radical expressions, the first thing we need to recognize is, do we have the same indices? In this example, we do. We have a cube root times a cube root. And when we multiply radical expressions that have the same index, it's pretty easy. All we do is multiply the outside numbers times the outside numbers and the inside numbers times the inside numbers. Here's what I mean when I say outside times outside and inside times inside. In these two expressions, the outside numbers are 3 and 6. In other words, 3 and 6 are the coefficients of these cube root expressions. So in this example, we would multiply 3 times 6. And when we multiply outside times outside, the result stays on the outside. Now we'll multiply the inside times the inside. That means multiply the number inside the radical symbol times the other number inside the radical symbol. So really, we're just multiplying radicand by radicand. 2 times 3 is 6. And when we multiply inside times inside, the result stays inside. And then, of course, because we're multiplying a cube root by another cube root, the result is always a cube root. So just to recap, anytime we're multiplying radical expressions where we have the same index, we multiply outside to outside, and that result stays outside. And then we multiply inside to inside, and that result stays inside. And the multiplication's done. Now all we have to do is make sure that 18 times the cube root of 6 is a fully reduced radical expression. And it is, because the radicand 6 is not a fraction, it's not negative, and it doesn't have any perfect cubes hidden inside of it. When I say hidden inside of it, I mean there are no perfect cubes that will evenly divide 6. So this is a fully simplified radical expression. Let's take a look at this example. Here we have a monomial that we need to multiply by a binomial. In other words, we need to distribute the 3 square roots of 3 to the 5 square roots of 3 and the minus 3. And the good news is we're multiplying square roots by other square roots. When we multiply expressions like that, we multiply outside to outside and inside to inside. So let's start by multiplying 3 square roots of 3 by 5 square roots of 3. On the outside, 3 times 5 is 15. And on the inside, 3 times 3 is 9. Now let's multiply 3 square roots of 3 by negative 3. Well, because negative 3 doesn't have a square root attached to it, the negative 3 is the outside number. So we still multiply outside to outside. So we need to multiply 3 times negative 3, which gives us negative 9. But then that still has to be multiplied by the square root of 3. So the final result is minus 9 times the square root of 3. Now the multiplication's done, and we just need to make sure that we have a fully simplified radical expression. Well, I notice that we can simplify the square root of 9 in the first term. The square root of 9 is 3. So really we have 15 times 3 minus 9 square roots of 3. And of course, 15 times 3 is 45. So we have 45 minus 9 square roots of 3. The second term, 9 square roots of 3, the square root of 3 is a fully simplified radical expression because it's not a fraction, it's not a negative, and there are no perfect squares that will evenly divide 3. And we can't combine the two terms, 45 and minus 9 square roots of 3, because they're not like terms. One of the terms is a constant term, and the other term is a radical term, and we can't combine constants with radicals. So this is our final expression. In this example, we're asked to multiply a binomial times a binomial, which is a FOIL situation. Again, I notice that we're only dealing with square roots in these expressions, which is good. So when we multiply these square root expressions by these other square root expressions, we multiply outside to outside and inside to inside. 2 times 3 square roots of 2 gives us 6 square roots of 2. That's first times first. Now let's do outer times outer. 2 times the square root of 3 is 2 square roots of 3. 4 square roots of 3 times 3 square roots of 2 is 12 square roots of 6, because 4 times 3 is 12 and 3 times 2 is 6. And then 4 square roots of 3 times a square root of 3 is equal to 4 times the square root of 9. The first term in this expression, 6 times the square root of 2, is a fully simplified radical expression, so we can't simplify that term. The second term, 2 square roots of 3, is fully simplified. The third term, 12 square roots of 6, is fully simplified. But the last term, 4 square roots of 9, needs to be simplified. The square root of 9 is 3. And we can continue simplifying that last term by multiplying 4 times 3. Now that each of our terms are simplified, let's make sure that we don't have any like terms that we can combine together. The first term is a square root of 2 term. I don't see any other square root of 2 terms that we can combine with that one. So that term has to stay as it is. The next term is a square root of 3 term. There aren't any other square root of 3 terms to combine with that one. The next term is a square root of 6 term. No other square root of 6 terms to combine with that one. And then the last term is a constant term. And we don't have any constants to combine with that one. So this is the best that we can hope to do, and this is our final answer. All right, let's take a look at one more example. In all the previous examples that we've done, we jumped right into the multiplication as soon as we realized we were multiplying radicals with like indices. Here again, we're multiplying square roots by square roots, so we can do that, not a problem. But sometimes it is best or easiest in the long run to simplify our radicals before we jump right into multiplying them. So that's the approach I want us to take on this problem. Let's first simplify the square root of 28 and simplify the square root of 20 before we multiply them together. The largest perfect square that will evenly divide 28 is 4. So we'll rewrite 28 as 4 times 7. The largest perfect square that will evenly divide 20 is 4. So we'll rewrite 20 as 4 times 5. Now we can take the square root of 4 and say that's 2 and pull it outside of the radical. But the 7 has to stay in because he's not a perfect square, nor is he divisible by a perfect square. So the square root of 28 simplifies into 2 times the square root of 7. Now let's do the same thing for the square root of 4 times 5. That expression simplifies into 2 times the square root of 5. Now that we've simplified each of these radicals, let's go ahead and multiply. Outside times outside, inside times inside. That gives us 4 times the square root of 35. And 4 times the square root of 35 is a fully simplified radical expression. Now, you could start off by multiplying 28 by 20, because that would give you the square root of 560. But do you notice now that we're dealing with the square root of a pretty big number, and simplifying that might get a little complicated? Whereas if we just simplify first, like we did over here, and then multiply, when we get to the end, we might not have to simplify. And even if we do, the numbers are going to be much smaller. So whenever we can, it's best to simplify radicals before we multiply them.